Alright, so we're here inside of Houdini. If you normally use other 3D programs, don't worry about it. This will just be, this is what I mainly use. I use Houdini and Redshift a lot, but the stuff that we're going to be doing is independent of any 3D program or render engine. So it's just going to be used to generate these renders that we're going to use in the composite, because I need something to generate them, and I need to explain some concepts that you need to understand, because like I mentioned, this is a course for compositing for CG art. So I assume that normally you do 3D work and you want to learn some compositing. So a lot of this stuff will be probably maybe familiar to you or maybe not, but we're gonna need to generate some renders. So yeah, Houdini for Redshift, but if you normally use other programs like Maya, Blender, 3ds Max, whatever, other render engines like V-Ray, Arnold, Octane, whatever, it doesn't matter. The idea, the concept should be almost the same throughout any render engine. This applies to anything. It's just generic 3D stuff. So yeah, we have a very basic scene here with a reflective material here, a subsurface material, which is the box, and then a reflective material, and just a ground that doesn't really have much interesting anyway, and just a sky, like just a light sun with a sky behind it. But before we get into any of the AOV stuff, I want to talk a little bit about stuff with colors, because what we're going to be using is we're going to set this up in ACES color space, or opencolorio, which is a way of dealing with renders and just with color data. So kind of why this came about is because before you had, and ACES, by the way, is pretty new, and I thought it would be interesting to just to cover everything throughout this entire course just in ACES, so you're kind of prepared for that thing, because it's an up-and-coming workflow. It's been around for a while, but now a lot of studios and people are starting to implement it, but there's still a lot of confusion around it. I'm not an expert on that. I'm not a color grader and I'm not a full-time compositor, but I know enough that I can work in ACES, so that's why I figured I'm gonna sort of talk you through that as well. So maybe you've probably, if you've done like any design work whatsoever or 3D work, you've probably run into an issue where maybe you rendered something out and then gave it to someone else, and then they start doing something with them in their program, look at it on their monitor, and everything looks completely different, and there's no way of telling where it went wrong. Because there's just like no way of knowing. So that's where opencolorio comes in. So opencolorio is sort of a way to standardize the whole color workflow that you have within your programs. So essentially what it does is, like, if you bring something in outside of opencolorio, for example, just a regular video or photo or whatever, you convert it into, you're gonna say, okay, what's the source, and then we're gonna put it into opencolorio, and then once it's inside of opencolorio, we can work with it within that workflow. It'll be the same for everybody, and everybody's gonna look at the same colors, and then we're gonna sort of output it outside of opencolorio. So then everybody is kind of on the same page. So you can say, okay, this is ACES data, it's ACES CG data, for example, we're going to be working with ACES data, and then we're going to look through it through a sort of a LUT that's going to convert these colors into something we can look at. So under the hood, it's going to work with this data, and then it's going to show us it in a certain color transform, which in this case we're going to be using a Rec 709 color transform. So if I put it to opencolorio or sRGB, somewhat the same. I could put it to Rec 709. I think I have it. Let's put it to sRGB. There's also here Rec 709. You can see they're pretty similar. Rec 709 is a little bit more modern, and most monitors support that. So now it's working in ACES and it's doing this. If you need to configure this, so let me just quickly explain how to configure that. So you can go to opencolorio website, opencolorio.org. You can go to downloads, and you could go quick start for artists, and you can download it. and then you can download the sample configurations. And then you can configure this for your programs. And actually something I recently discovered, because I was always setting it in my Houdini environment variable. If you don't use Houdini, don't worry about it. There's actually a way to set this globally for all your programs, which I recently discovered. So if you can go to your, if you're on Windows, on Linux it's going to be a little bit different, but if you're on Linux, you're probably technical enough that you can also figure this out. You can just Google how to do this in Linux or on Mac or whatever. So you're going on Windows, at least you're going to right click, go to properties on your computer, and you can see I have all my specifications here, so blah, blah, blah. No, I'm not bragging. I just have an awesome computer. Then you go to advanced system settings, and so you need to first, by the way, when you extract this, you can just extract these things, and it's gonna get a folder. Just put that folder somewhere on your computer, maybe on the C drive, on the root, or put it just somewhere. You can also put it on a network location or something like that. Anyway, when you do that, after that, you can go to these advanced system settings, go to environment variables, and make a new environment variable and call it OCIO. So like I put here, so OCIO. And then put the variable value to the config thing that's inside the download that you have. Depending on that, I'm not sure which download this gives you. There's a couple of downloads floating around. I think this might still give you the 1.03 version. The newest one is 1.2, but it doesn't really matter if you're 1.03. Anyway, so so in my case, I've configured it for ASUS 1.2, and I'm putting this to the ASUS config folder. And if you do that, then all of your, well, most of your programs that have a ASUS plugin, so Fusion has one. If you configured it for After Effects, for example, you also have a plugin for After Effects that you need to install separately. But for this course, again, we're going to use Fusion. It should recognize it. Houdini should recognize it. It should all be universally recognized. In terms of Houdini, you can also just put it on in your environment folder, but this is just the default thing. If Houdini doesn't recognize it, I guess you can go to, let me just grab it. So if Houdini doesn't recognize it, you can put it on your, you can go to Houdini environment folder, open the houdini.env, and you can put OCIO and then put it to wherever your config is. But again, this should, if you configure it globally with the environment variable in Windows, this should pick up on everything. Anyway, so that's with that out of the way. I'm going to get more into also how to use it in Fusion later, once we get to that, to those configurations. But for now, just put your Redshift render to opencolorio or your other render engine. Or if you're not following along in 3D, that's also fine. You can also just not follow along in 3D, completely fine. It's going to be about the concepts that I'm explaining here. So fundamentals, if you watch Houdini 101, then you're going to fundamentals. Here he's coming with the fundamentals again. Anyway, you have the here the Rec 709, so put it to that. So now we're looking through it through ASUS and a Rec 709 conversion. And if we later look through this in Fusion, it's going to look exactly the same. So that's going to be good. So the color should be completely one-on-one. Anyway, so we have some simple objects here. So I have all of these things here, and I have some AOVs here. So I just have Redshift set up with some basic settings. Nothing too interesting. Just you don't have to match this. It's just a very simple setup, just with some global illumination, just a couple of samples, very simple. And if I look down here on this thing, and by the way, it's not set up with the AOVs yet. So let me just go to that one. So if I look here, I have a drop-down menu with a whole bunch of stuff. I'm going to explain how to set this up a bit, but let me just explain all of these things. So yeah, right. So if I just go through it, you can see this is my beauty. The beauty is just the main render that just the main beauty render. That's why it's called beauty. But we can look at separate elements of these beauty renders. We can look at the diffuse, we can look at reflection, we can look at refraction. So these are all the things that I mentioned. GI, so that's the bound light, global illumination, specular. So we have some nice specular on one of those things. We have the Z depth, which is the depth channel. I'm going to explain more once we get there. But we have all of these things. And later in compositing, we can combine all these elements. So essentially, what you need to recreate a beauty render in compositing, we're going to talk about why it's useful to recreate a beauty render later. I briefly showed it in a previous video, so if you render out separate AOVs, you have more control over your final render during the composite. And so the basic things you need is like just diffuse, reflection, refraction, GI, specular, subsurface scattering. You might need additional stuff, like if you have caustics, you need a caustics pass. So it kind of depends on your render, but if you're a CG artist, you probably know what you're gonna need. And you might also discuss, if you're working with a separate compositor, you might need to talk to him or her, like what passes would you want. And there's also additional data passes like the Z pass here, which is a depth pass, which means so in Redshift, the stuff close to the camera is going to be black, and far away from the camera is white. Some render engines it is reversed, so then it's going to be black in the depth and then white in the front. In the compositor, we can just tell it to like to convert it. So that's going to be depth, and that can be used, for example, to do depth of field in compositing, which is something we can do. So that's a useful depth pass. There's other passes. For example, here we have a normal pass. So that's just it has all of the normal information. So we have like if we have our normals on our objects here, they're essentially just it's a color pass here. So it has the information of how are the normals facing, and you can use that in compositing to do some relighting. For example, I can add some extra, like I can change my lights a little bit in compositing. We're gonna get into that. So that's super cool stuff. And position pass here saves the position of every element. So let's say I have my box here, and I mean right now it has a world transform, but so it's essentially it saves the, let me just make a test thing here. So it saves the information of where is my stuff located. Let's say I make a box in here and I do some transforms on it. On here you can see the position here changes. And like if I'm to make a, if I say CD equals position, and if I then move it, you can see colors change. So you can see if I move it, you can see the colors change. So that's why, like, if you watch my Houdini 101 course, if you want to learn Houdini, by the way, you can check that out. You should know all about this. But position is a vector. So there's three components, X, Y, Z, and we can put those in a color. So that's what we're doing here. So you can see colors change. And your position AOV essentially has the position channel as a color. So essentially that's what this is. And we can do super cool stuff with this in compositing later. So we can extract the position, the 3D coordinates of something, and put it in our and use it in our compositing package to do cool stuff. Like we can put one object behind another object based on the position. So very cool stuff. So essentially that's different AOVs. There's a lot more AOVs. We're gonna get that into a later video when we do an actual production shot. So this shot is just gonna be the just a very basic shot. Like you see, it's just, I mean, unless you have a client that specifically wants these three objects, this is not gonna be something that you're gonna run into. It's a very 90s looking render. But yeah, so this is a basic thing. So let's talk a little bit about how you could set up AOVs like this. So this is going to be a little bit different depending on your render engine. In Redshift, you can do it either on your ROP, your render output directly. So if I just turn this off, then I can create with a plus icon on my output AOV tab. I can create AOVs here. So you can see I can create these AOVs, and or I can, what I prefer to do is create a Redshift AOVs tab, AOVs, and you can put that in there, and we can configure our AOVs in here. Right, so again, click plus icon, say diffuse lighting is the default diffuse lighting. Of course, like I mentioned, you can create all these basic things. I can also, I made a preset with, for example, all my basic things that I use a lot. So just, you can save that out with just a save preset, and you can do that, but let's just do it manually now. So diffuse lighting, reflections, let's just create a couple already. Let's do refractions, we need that one. We need global illumination here. We need specular, where is it? Specular lighting, right? Specular lighting. Which one do we still? Oh yeah, subsurface scattering, where is it? Subsurface scattering. I always lose track of where everything is. There we go. You can see there's also these raw passes. We're going to deal with that in the production scene. There's cool stuff that you can do with that. But for now, you just need the basic ones, right? Subsurface scattering, and we want the z depth. So that's the one that we just made. So z depth. We want position, world position. And we also have these puzzle mats. So puzzle mats are, for example, didn't discuss those yet. We can use those to mask stuff out. So for example, I have my objects here have an ID, so object ID. You can also give materials an ID, but here they're object IDs. So object ID and object ID, super cool stuff. Can use that to, for example, go in here and do puzzle mat. Can go to puzzle mat and I can say object ID and say 1, 2, 3, and we need 2 because we have too many. That's where also cryptomat comes in. For example, cryptomat can be super useful. We're going to get into that in the production scene again. So this is going to be this video is going to be like the basics. Although we're going to do some quite cool stuff, we're going to learn more in the other video. One step at a time, right? All right. So there's another puzzle mat. 1, 2. Oh wait, sorry. 1, 2, 3, 4, 5, and say 6. Object ID. All right, so now we have that configured with all of our things. Yeah, I mean, you could, like, if I now drag this in there, this should work. But I have some stuff that I need to explain now as well. I need to talk a little bit about bit depth. So but let's first let this render. So now it's going to use this AOV and it's going to complain that it has some duplicate AOVs. It's probably because we probably have a diffuse. Yeah, we have an extra diffuse there. It's because I just clicked the plus button to create some and it always defaults to diffuse. Let's press render again. All right. So we have all of our things here. You can see the Z depth here is now, it's pretty wide. So let's talk a little bit about these bit depths because we're going to render as EXR. So EXR it's kind of the default for renders. It's a it can contain floating data. If you're used to using, like in Houdini, for example, you probably already know what that is. But essentially, like if you have, for example, a PNG or a JPEG, they use integer color. Let me just go into After Effects real quick. So, so now I have my After Effects here set to 8 bits per channel, and I have some gradient ramp. Let me maybe make this a little bit more extreme. Right, so let me zoom in, and you can see there's these bending effect. It's called bending. You can see it's not a smooth gradient. It has like these color bands. And if I look in my info panel here, you can see if I go through it, you can see it go from 0 to, well, if it was white here, then it would go from 0 to 255. So it has 256 steps between that thing. That's called 8-bit color. So a JPEG, for example, has 8-bit color. And so I have these steps. You can also have 16-bit colors, and you have a little bit more information, but it's still going to be integers. So in 3D, we're dealing with linear color information. So we're going to have like if I let's say if I make another thing here. Oh. Right, so we're back. Houdini just crashed, but we're back. And by the way, you need to go in your puzzle mat as well and call one puzzle mat 2, because it cannot have duplicate names, else it's just gonna override it. Yeah, talking about the floating stuff. Let me just let's turn this off. So if we're floating like floating colors, like instead of something being from 0 to 256. It can be, for example, like if you have black, it's going to be 0, white is going to be 1. But we can also have super bright stuff. If you have an HDR TV, like that's also what HDR TVs have. Like they can go beyond bright, so there's more gradation. So like for example, if you're gonna look at the sun is going to be super bright. It might be like 16 or 20 or whatever. So it's still white, but it's beyond white. And if we then like if we have a linear color information, we can turn down the brightness in compositing, and we're still going to get all of the information that's there. So, and if you're capping it at 255, so 0 to 255, like if you grade down your image, you're never going to get the color information back. It's going to be white, and then we're going to grade it back, and like the color information is never going to it's never gonna come back to like where it was. So that's kind of the problem. Maybe I can make a demo real quick of that. 1 second. All right, so I changed my sun here a little bit to be here in the back. So if I turn it down here, you can see, well, clearly we can reveal the sun. But let's just render this out. So now it's like way too bright. So I'm gonna render this to disk. Just as an image. It's gonna be super bright. So we're not gonna have any detail there with the sun. I'm gonna load that image into After Effects. Again, I know that we're not gonna composite in After Effects, but After Effects can actually deal with the integer color thing, which you don't want to do. Or you can also do that in Photoshop. Let's just wanna do a quick example here. So let's wait for this to render. Boop, there we go. Let's jump into After Effects. Let's go in here, test frame. I need to go to project, dump my thing in there. All right, let's put the thing in there. All right, so now we're capped here at 255. Because we're set here to 8 bits per channel. So let's do an exposure. Right. And let's turn it down. So you can see I'm turning it down, but nothing's happening. Like I'm not getting any of the detail back because it's not there. We're in 8 bits per channel. But let's say I switch to 32. Right. Switch to 32. And you can see now I'm on 32 bits per channel. You can see also the thing here is like you can see these values like are 0 point whatever. If I make it super bright, you can see I'm well above it. You can see all this information is still there. So that's why you really want to render at EXR, so floating stuff. So there's also a difference here between 16-bit colors and 32-bit colors. So most of the stuff you're fine with 32-bit float. And 32-bit float essentially just has to, 32 or 16, essentially just has to do with how much information can I store in this thing. For most color information, just renders. 16 is completely fine. You don't really need more than that. Where 32 can come in is data channels. Like for example, if I have the position pass, why it's not doing the thing? Why is my position not there? Let me just render. I'm just gonna drag my my other thing in. Let's just check. Do I have? All right. Let me just render this real quick. Just by the way, turn down my brightness maybe. So for example, data passes. There it does make a difference. So we just go to P. All right. because this contains data, and maybe you do need the precision for something like that. So you might, like if you're gonna use the position channel, you might actually need, like if you have a very large scene, stuff is all over the place, then the extra precision of 32-bit might make a lot of sense. That's why a lot of these passes are also by default set to 32-bit. So let's go there. As you can see, you can change it for per pass, and on your thing here, on your output, you can also say, do you want half float or you want full float EXRs? So that's where kind of that comes in. So I kind of hope that it's clear why you want to learn linearly. So if you were still using for your CG renders like PNG or whatever, stop doing that. Like just use EXRs. EXRs also, they can hold all of these passes in one file. Sometimes you might not want to hold it in one file. You might want to split it up. So let's talk a little bit about that. So if, for example, if I have this, I just made this render, right, with this thing where I can turn it down. So I put it in one file. So if I put my extractor here, why didn't it save all of the? Just do another render. Just put in the AOVs that I had here. And let's just render it again. Render to disk. So your like an EXR can hold all of these channels in one file. Like with a PNG, it will always split it out. In After Effects, you probably want to work, by the way, sometimes with PNGs, because the EXR support in After Effects is pretty terrible. It got them better with some of the later releases, but it's still just not ideal. Yeah, it's gonna complain because it's not saved out yet. Let's just do a reload. All right. All right, let's try the extractor thing again. Why is, oh, I was doing it on the white solid. All right, here we are. Okay, so you can see this one EXR file can hold all of these channels. You can also split them out depending on your work. Like some people or studios might prefer splitting it out. Depends on your compositing program. Depends on how many AOVs you have. If you have like one EXR with like a ton of heavy passes and you're rendering 8K or whatever, your EXRs might well be a gigabyte or more per frame, which is not ideal if you're not going to use all of these passes. And you have, for example, you have EXRs can have multi-part, which means they can sort of like your compositing program can load one pass at a time, so it doesn't have to load the entire file, but that doesn't necessarily work properly in all compositing packages. I'm not sure about Fusion. I know Nuke can do it, but it also apparently depends on your server. Like if you have a file server, apparently it's very specific about like the file system and stuff, if that actually works. So there might be cases where you don't want to use multi-layer EXR. In that case, what you would do is you can, in your name, you could put $AOV. And then it's going to be, I want no multi-layer EXR. And so file format EXR, no multi-layer EXR. And then I'm just going to render to disk. Something is spinning here. There's something. I should check my fans if there's. I think there's a cable hitting. Yeah, you cannot hear it in the audio, but I'm gonna check what's up with that a little bit. So let's wait for this to render. We can check in our folder, and once it saves all of, yeah, right. Now you can see it's gonna save all of these things out. Let's do details. So you can see where I have all of these, and you can see some are very small, some are very big. So sometimes it might make sense to split it out and just load them separately. In other times, I usually work with multi-layer EXR, but Your results may vary, so depends on what you're doing. Yeah. Anyway, that is essentially just kind of what this is. And there's like again, there's a whole host of stuff you can also make. You can make custom AOVs to hold arbitrary data. Like I can, for example, let me think of a good, like let's say I have an attribute on my on an object. Like I can, like let's say I make a box here. Like let's say I have a box here. I can, let's say attribute create, and I call it like cheese. Put it to 1, and so now I have an attribute cheese on some faces. Let me just put it on. I only want it maybe on this face, right? So point attribute. So then I could say in the box material that I want. Well, I'm not sure what this is called. Oh, that's the one. Okay, I'm gonna put the. Let me check which one the box has material. I need to put it in a. Oh yeah, it was gold before. That's why it's called gold and called box. Right. So I'm gonna put it into a material builder because I actually need. In order to demo this, I needed to be in a material builder. I'm gonna put it in there. I'm gonna assign that to my box. And for example, there I can say store, let's say scalar to AOV attribute. Point attribute, so I want to store scalar. It was called cheese. I want to store it into an AOV called cheese, and then in my AOVs I can say we were working on this one. I think we can say custom cheese. Let me actually select, by the way, one of the front faces. Already. Oh wait, I was doing it in the. Let's do it in our actual box here. So let's do it on this one. Cheese and 1. All right. Right now we can. So now, for example, we could render. Just only do that part. Cheese. You can see now my faces are contained in that attribute. So you can also do custom AOVs. All right. So let me just remove the cheese here, and let's remove the AOV stuff because I want to use multilayer for my example. And let me change the sun a little bit, and I can probably let me just also change the samples. This is way too high. And let me just change my light a little bit. Let me just rotate it. I'm just gonna rotate it over here. It's probably easier to see. So this is that we have something that's maybe a little bit more. All right, maybe we do want the sun back there a little bit. So we're back with what we had before. Let's just render this out as a frame. So yeah, that's gonna have all of our AVs there. I'm just gonna render it, and then once it's rendered, we can jump into the into Fusion and we can start compositing this. So in the next part, I'm gonna teach you all about configuring Fusion. I'm gonna teach you first how to configure it both for Fusion standalone and for Resolve, so you can follow along with this either in Resolve or in Fusion standalone, doesn't matter. I'm going to be comping in Fusion standalone, but and I'm going to also explain why I prefer doing this in Fusion standalone. But again, Resolve is free and Fusion standalone is paid. So anyway, let me render a frame and I'll see you in the next part.